My friends again, and welcome to this new video into which, my friends, we are going to proceed or continue answering questions of Pearson Edexcel International IGCSE, and the questions belong to year 2024, the 17th of May. As you see, my friends, we are going to answer the chemistry questions today. Hopefully we are going to start with the English ones later. So we answered in the previous videos questions number 1, 2, 3, and 4. Today, my friends, now in this video we're going to go through question number 5 of the same past paper. The question is about chromatography. So, my friends, what is chromatography? Chromatography, my friends, depends on the ability of moving phase to separate a mixture of chemicals that are detained by a stationary phase. As you see here, my friends, we have this TLC, or we call it thin layer chromatography, and we have the mixture here. We have two lines to be used. The first one is called baseline, and generally the baseline is used with or written by a pencil. And here we have the solvent front. What is the definition of the solvent front, my friends? Can you remind us? Yes, the solvent front, my friends, generally is the farthest, let's say, distance that the moving phase can move or can climb over and reach. And we have what else? What else here? We give the names. We have here, this is called the stationary phase, and we talked about it before. The stationary phase, generally, my friends, is silica gel, or maybe this is the chromatography paper, so that if you want to solve this problem, sometimes students get confused. What shall I write? Do they refer to the whole chromatography paper, or do they refer only to the silica gel, which is the stationary phase? Here, my friends, can teach you a very simple trick. You can write the stationary phase loaded over the chromatography paper, which will solve the whole problem. Here we have the solvent. I guess this is the solvent because we have here the sides of the liquid, which is the solvent, or we call it the moving phase. And the question, I complete the diagram by adding the missing labels. We added them. Question number 2, give a reason why the baseline is drawn in a pencil, using a pencil. As you see, my friends, here, generally we use TLC, or thin layer chromatography, in order to separate mixture of chemicals. So this is here, this is the mixture, and those are the components of the mixture. If I draw the line, this baseline, with let's say a pen, which of course is made up of ink. The ink could be dissolved by the solvent here, which is the moving phase, and it will travel with the components which we want to separate, and it will give us what? False results. So that we use the pencil. The pencil is made up of graphite, and graphite generally is not soluble into the solvents, specifically the traditional solvents, water, for example, methanol or ethanol, that are the most common let's say solvents or traditional solvents used. So using the graphite pencil is better, so that it will not, so the pencil or the graphite will not travel like the ink with the other components and give us false results. Here we have the explanation written in let's say an academic way. Pencil lead graphite is insoluble in the solvent, so that it doesn't move with the moving phase. Using a pen, the ink will dissolve into the moving solvent and separate, ruining the chromatogram. This is, my friends, the chromatogram. The chromatogram is the chromatography paper and the stains or the spots on it. Now let's go to the practical part of the question. In here, my friends, they say diagram 2 shows the chromatogram produced from 4 different food colorings. This is food coloring W, this is food coloring X, the component of X, those are the components of Y, and this the only component of Z alone. So what is the question here? Which 2 food colorings contain the same dye? Of course, they should travel the same distance, so that we can say that they have a component in common. Look at, for example, Z and Y. Z and Y, the components here of Z, and this is the component of Y. They haven't traveled the same distance. Y and X, of course, the same. They haven't traveled the same distance. While when we go through Y with W here, Y and W, they travel the same distance. This refers that this spot and this spot belongs to the same chemical compound. So we say the mixture Y contains a component, the component W. So W is one component into the mixture Y. So because they travel the same distance, so the answer to this question here, my friends, is Y and W. The answer is B. Now let's go to the other question. Calculate the RF value of the dye in food coloring W. Here, my friends, the main rule is RF, or the retention factor, equals distance traveled by the spot. This is the distance traveled by the spots, and we call it D1, as you see here, over the distance traveled by the solvent front. This is the solvent front. Here we call it D2 in centimeters. So we divide them over one another. Teacher, how can I answer this question? Generally, you have to get a ruler with you to the exam. So you are going to measure this and measure this one. Let's say that, for example, this is 5 centimeters, for example, and this is 25 centimeters, let's say. We divide 5 over 25, and the result is going to be, I think, 0.5, and the RF is going to be 0.5. And again, my friends, this value here, RF, has no unit. Why doesn't have a unit? Because here you are dividing centimeter distance over distance, centimeter. So there is no unit. I guess we have finished answering question number 5, and we should go to question number 6 in the next video.